So we'll talk about quadrilaterals, and basically if it has four sides, it's a quadrilateral. Okay, so the square is an example of a quad. It's four sides the same length and the opposite sides are parallel. All four angles are right angles. Okay, and the double dash signifies the same length. A rectangle. Each pair of opposite sides are equal in length and are parallel to each other. Okay, and all the four angles are right angles. A parallelogram. A parallelogram has opposite sides that are parallel. This is parallel to this side, and this is parallel to this side. This side is equal to this in length, that's equal to that in length, and the opposite angles are equal. A rhombus has four equal sides. The opposite sides are parallel to each other, like that, and the opposite angles are equal, and these are equal. This angle here is equal to this angle here. And okay, we'll talk about diagonals now. So for a square, the diagonals are equal in length and they bisect each other at 90 degrees. So this length is equal to this length and that length is equal to that length. For a rectangle, the diagonals are equal in length and they bisect each other, but there's no mention of 90 degrees. And for a parallelogram, the diagonals bisect each other, so they divide each other into two equal lengths, but they're not equal to each other. Now this length is equal to that, yes, and then on a different measurement, this length is equal to that. And for the rhombus, the diagonals bisect each other at 90 degrees, as they do with the square. And this is equal to this, and this length is equal to this. And just to make mention of the angles of a quadrilateral, the interior angles of a quad add up to 360, because if you think about it, if you have a quad four-sided shape and you throw a diagonal through there, you actually end up with two triangles. The sum of the angles in each triangle is 180, so you have 2 times 180 is 360 degrees. Now here's an example using all of that information. So we're given a parallelogram here, we know we're given this angle in here and this angle there, and we're asked to find the angle BCD. Okay, well BCD is just 115 because it's equal to the opposite angle there, and I have that noted here. Okay, the angle ABD, so this angle in here, to find ABD we need to consider the fact that we have two parallel lines and a transversal, and that's 28 here, so that's equal to it because these are parallel, so that's equal to that, so that's 28 degrees. Okay, and then ADC, so the angle ADC, angle ADC is all of this angle here, okay? And again, we've two parallel lines, and we have a transversal now running this way. So if we look for our C shape, we can see that if this is 115, then this plus ADC must be 180, because interior angles add up to 180. So using that, we say 180 minus 115 gives us ADC. All of this is 65. Okay, all of that angle is 65. And then DBC, so DBC, this is DBC in here, this angle here. Okay, we know this is 28, we know this is 115, we know this is a triangle, so this must be equal to 180 minus 118, 180 minus 115 minus 28, 37 degrees. Now, let's talk about congruency and congruent triangles. Shapes are congruent if they are the same size and they have the same shape. So these two triangles are congruent, and when they're congruent, their angles are the same, and they have sides that correspond in length as well. So this angle is the same as this angle is the same as this angle, therefore that must be the same as that. This side corresponds to that, same length, this to this, and this side to this side. But there's different cases, 4 different cases where triangles can be seen to be, or proven to be, congruent. And the first one is if the 3 sides in one are equal in measure to the 3 sides in the other. The second one is if 2 sides and the included angle, so 2 sides and the included angle in one triangle is equal to 2 sides and the included in length and size is equal in another triangle. The third case, if we have an angle, a side and an angle, so we have maybe an angle here and an angle here, A, B, and a length x, and in another triangle we have A, B, and a value x or y that's equal to x, then these two are congruent based on angle, side angles. So 2 angles and the side between them in one are equal in the other. So the fourth case then is when we have a right, it's the right angle, a hypotenuse, and one side equal in length. So if we have 2 triangles and there's a right angle in both, the hypotenuse in both is equal in measure, and one of the other 2 sides is equal to one of the other 2 sides in both triangles, then those 2 triangles are congruent. And if we have like a triangle ABC and triangle DEF and they're congruent, then we can use this notation here. Triangle ABC equals triangle DEF. And also just to note that if 2 triangles are congruent, then the sides opposite the equal angles in the 2 triangles correspond, and also the angles opposite the equal sides in measure correspond as well. So let's look at a couple of examples now. Okay, so why are these 2 triangles here congruent? Okay, well, they're congruent because of the case, the second case here, where we have a side angle side. So we have a side here that's equal to a side there. We have an angle of 35 degrees, an angle of 35 degrees, and we have a side here equal to that side there. So we have a side, an angle side corresponding to this side, angle side. They're congruent. Now, example 2 looks at kind of proving that triangles are congruent before we're not even asked to do that really, but often helps do that before you proceed further. Okay, so we're given a triangle ABC, and D is here, and AC is equal to, in length to AB. AD bisects this, so this angle is equal to this angle because it bisects it, it divides it in 2. We have to prove that the triangle ACD is equal to the triangle ABD. Okay, so in ACD and in ABD, AC is equal to AB, so those 2 sides are equal. We're told that. And AD is equal to AD, and that's the side that's common to both triangles. Okay, so we have 2 sides equal now. Now, the angle CAD is equal to the angle BAD because this bisects that angle into 2 equal parts. Okay, so we have a side, an angle, a side, and we have a side, an angle, and a side, all equal. So therefore they are congruent, those 2 triangles. Okay, but we're looking, to prove that the size of the angle ACD, that this angle is equal to the size of this angle ABD. This is what we're looking to prove. That angle is equal to that angle. But if the triangles are congruent, then they're the same. This angle is the same as that. This angle is 90, so that must be equal to that. But if not only for that, they're both they're corresponding angles because they're both opposite the corresponding side, that is AD. So this is opposite this side, that's opposite that. They're corresponding, so they're the same.